In this video, we're going to talk about how to solve Bernoulli's equation as it relates to differential equations. So the first thing that you need to do is write the equation in standard form. And that's in this form: y prime plus p of x times y is equal to q of x times y raised to the n. Now once you have it in this form, you need to identify p of x and q of x, and also the value of n. Next, you need to determine the integrating factor I of x. And that's going to be e raised to the integral of 1 minus n times p of x dx. Now once you have the integrating factor, you could use this equation to get your final answer. Y raised to the 1 minus n is equal to 1 over I of x times the integral of 1 minus n qx ix dx plus the constant of integration. So let's work on an example. So let's say we have this equation y prime plus 2 over x times y, and that's equal to x squared y to the third. So it's already in standard form. So we could see that p of x is 2 over x. So let's write that. And then q of x is x squared in this example. And we could also see that n is equal to 3. So now let's determine the integrating factor. So we said that I of x is equal to e integral 1 minus n px dx. So we know that n is 3, so this is going to be 1 minus 3. And p of x is 2 over x. Now 1 minus 3 is negative 2. And negative 2 times 2 is negative 4, which I'm going to move that to the front of the integral. Now the antiderivative of 1 over x is ln x. And I'm going to move the negative 4 to the exponent of x. So this is e ln x to the negative 4, which is x to the minus 4, or simply 1 over x to the fourth. So that's the integrating factor. So now let's find a general solution using this equation. So all we need to do is plug in what we have, find the integral, and that's going to be the answer. So we have y raised to the 1 minus n. So that's y raised to the 1 minus 3. And then 1 over I of x. I of x is 1 over x to the fourth. And then we have the integral of 1 minus n, so 1 minus 3. Q of x is x squared. And then I of x, which is 1 over x to the fourth. So we don't need this anymore. Now 1 minus 3 is negative 2. And 1 divided by 1 over x to the fourth, well, that's going to be x to the fourth. So we have the integral of negative 2, and then x squared divided by x to the fourth. That's going to be 1 over x squared. But I'm going to rewrite that as x to the minus 2. So I can use the power rule. So the antiderivative of x to the negative 2, we need to add 1 to the exponent. Negative 2 plus 1, that's negative 1. And then divide by that result. And then plus c. So now we just got to clean this up. We just got to simplify the expression and get the answer. So we have negative 2 divided by negative 1. that's going to be positive 2. And x to the minus 1, we can bring that back to the bottom. So that's going to be 2 over x, and then plus c. Now our next step is to distribute x to the 4 to 2 over x and to c. So we're going to have y raised to the negative 2, and then x to the 4th divided by x is just x cubed. So this is 2x cubed, and then plus c x to the 4th power. Now typically, if you have negative exponents and if you can get rid of them, it's a good idea to do so. So we can say the final answer is 1 over y squared, which is equal to 2x cubed plus cx to the 4th power. And so that's how you can solve Bernoulli's equation as it relates to differential equations. Now let's work out another example. So let's say we have this equation, y prime is equal to 3x squared times y, and that's equal to 4x squared or y squared. So now that you understand the process of solving Bernoulli's equation, go ahead and try this one. So first, we need to identify p of x and q of x. P of x is everything in front of y in terms of x. So let's write that at the bottom. So p of x is 3x squared, and q of x is right here. Keep in mind, the standard form is y prime plus p of x y, and that's equal to q of x times y to the n. So we can clearly see that q of x is 4x squared in this example. And then we need to get n as well. So we can see that n is 2. Now the next thing we need to determine is the integrating factor. So I of x is equal to e integral 1 minus n p of x dx. So n is 2, and p of x is 3x squared. So 1 minus 2 is negative 1, and then we have a 3 in front of that, so that's negative 3, which I'm going to put in front of the integral. Now the antiderivative of x squared, that's going to be x cubed divided by 3. And so we could cancel the 3's. Negative 3 divided by 3 is negative 1. So we have e raised to the negative x cubed. So that's going to be the integrating factor. So now let's use the last formula that we need to use to get the answer. And just like before, plug in everything, integrate, and then just get the answer. So this is going to be y raised to the 1 minus n, or 1 minus 2. And then I of x is e raised to the negative x cubed. And then we have the integral of 1 minus 2. Q of x is 4x squared. I of x is e to the negative x cubed dx plus c. Now I'm going to focus on this integral because in order to find the antiderivative of that expression, we need to use u substitution. But first, let's simplify it. So we have 1 minus 2, which is negative 1, times 4. So we have the integral of negative 4x squared e to the negative x cubed dx. So we're going to make u equal to negative x cubed, and du is going to be negative 3x squared dx. And solving for dx, that's going to be du divided by negative 3x squared. So I'm going to replace negative x cubed with the u variable, and dx with du over negative 3x squared. And so these will cancel. And now I have the integral of e to the u du, but there's a constant in front of that, 4 over 3. The antiderivative of e to the u is just e to the u. And then we need to replace u with negative x cubed. So this is going to be 4 over 3 e to the negative x cubed. So we have y to the 1 minus 2, which is y to the negative 1. And then this whole thing right here, we can replace that with 4 over 3 e to the negative x cubed, and then plus c. So now let's distribute this term to these two terms. So if we multiply it to the first one, e to the negative x cubed divided by e to the negative x cubed, they will cancel. And so this is just going to leave behind 4 over 3. And then if we distribute to the constant c, it's going to be c over e to the negative x cubed. And so y to the negative 1 is equal to all of that. Next, we need to take this term, move it to the top. And y to the negative 1, we can write that as 1 over y. So that's equal to 4 over 3 plus c e raised to the positive x cubed. Now, to make this y, we simply need to raise both sides to the negative 1 power. So all we need to do is flip the fraction. This is going to become y, and on the right side, we're going to have 1 over 4 over 3 plus c e raised to the x over 3. Now I'm going to multiply the top and the bottom by 3 over 3. This will simplify the complex fraction. So in the numerator, 1 times 3 is 3. And then we have 4/3 times 3. The 3's will cancel, giving me 4. And then this times 3. So this is going to be the final answer. So we got rid of all of the negative exponents. And that's it. Here's another problem that you can work on. Sometimes this computer has issues. X squared y to the 4th minus 1 times dx plus x cubed y cubed dy equals 0. Now, just looking at this equation, it doesn't look like it's in the appropriate form. So we need to adjust it and put it in standard form. Now the first thing we need to get is y prime. And we have dx and dy separately, but keep in mind y prime is dy over dx. So what we need to do is divide both sides by dx, or in fact divide every term by dx. So we're going to have x squared y to the 4th minus 1, and then dy over dx, we can replace that with y prime. So we're going to have plus x cubed y prime, and that's equal to 0. Now, in standard form, the only thing that should be in front of y prime is 1. So we need to get rid of x cubed y cubed. So divide everything, each term, by x cubed y cubed. So these will cancel. Now, x squared divided by x cubed, that's going to be 1 over x. And then y to the 4th divided by y cubed, 4 minus 3 is 1. So that's just going to be y. And then we have minus 1 over x cubed y cubed plus y prime. And 0 divided by anything is virtually 0. Now let's put it in standard form. I'm just going to rewrite the standard form for Bernoulli's equation. It's y prime plus p of x times y, and that's equal to q of x times y to the n. So we should put y prime on the left side. Now, notice that we have y to the first power times something. Here we have y to the first power. So this term correlates with p of x times y. So I'm going to write that as the next term. Now, this indicates that we should move this to the other side. So it's going to be positive on the right side. And then the q of x part, that's going to be 1 over x cubed, which I'm going to write it as x to the negative 3 for now. Now, y to the n, that's 1 over y cubed, which I'm going to write it as y to the negative 3. So if you bring x and y to the top, positive 3 will change to negative 3. So now we have the differential equation in standard form. Our next step, as usual, is to identify p of x, which we could see is 1 over x. And then we need to identify q of x, which is x to the negative 3. And then n, we can see that n is negative 3. Now we need to determine the integrating factor, I of x. So as always, I of x is going to be e times the integral of 1 minus n px dx. So n is negative 3. This is 1 minus negative 3. And then p of x is 1 over x. Now 1 minus negative 3, that's the same as 1 plus 3. So that's 4, which I'm going to put in front of the integral. And the antiderivative of 1 over x, as we know, is ln x. So this is going to be 4 ln x. And so that's ln x to the 4th power. And e raised to that is just going to be x to the 4th. Keep in mind, the base of the natural log is e. So these will cancel. So now we have the integrating factor, I of x. Now we could use our final formula to get the answer. So this is going to be y raised to the 1 minus negative 3. And then I of x is x to the 4th. Q of x is x to the negative 3 times I of x, and so forth. So 1 minus negative 3, we know it's 4. And so this is going to be 4 as well. Now x to the negative 3 times x to the 4. If we add the exponents, negative 3 plus 4 is positive 1. So this becomes just 4x. The antiderivative of 4x is going to be 4x squared divided by 2. And 4 divided by 2 is 2. So we have 2x squared plus c. Now we need to distribute this term. So this is going to be 2x squared divided by x to the 4th plus c over x to the 4th. So x squared divided by x to the 4th. 2 minus 4 is negative 2. So we can make it positive 2 by putting x on the bottom. So this is what we now have. Now to simplify this expression, I'm going to multiply each term by x to the 4th. So on the left I have x to the 4th, y to the 4th, and then x to the 4th divided by x squared. 4 minus 2 is 2, so that's going to be 2x squared. And then these will cancel, giving me the constant c. Now I'm going to take this term, move it to this side. So the final answer is going to be x to the 4th, y to the 4th, minus 2x squared, which is equal to c. And so this is it.